Alright guys, welcome to the third part of this tutorial. We'll keep implementing our snake game. So let's just create our board. We have to create a board. Oh, we have already created a board. We just have to expand it a little bit. So we want to create a place food. Okay, and this will just place food on our board randomly. So every time our snake catches some food, we need to place another food. So that's just for that. And we also need a very strange function. I'll implement it later on, but just be warned. Okay, so I'll place food right here. Okay, board place food. Okay, and this will return a void, which means doesn't return anything. So we'll keep going through the algorithm of trying to find a suitable position for our food until we have found a suitable position of our food. So we need an index, and for that we use this function right here. So rand generates a really big number, and we're going to use the modulus operator with this value over here to get a value between 0 and width times height, which is basically the size, right? So we can also do like this, grid size. It's the same thing. And now we're going to create a reference to our index. Okay, so we'll say block. We're going to get the block from the random index, and if this block is empty, that means we have just found a suitable place to store our food. And we'll say that block equals block food, and we'll push back means to add to the vector of food. We'll add a new position, right, which will just be index divided by width, index modulus width. So first, the reference we're using tells us that we want to work with this directly. So instead of copying the value, we'll say that okay, we're going to work directly with the grid index. So this is like an alias. If we didn't use this, right, we would have to use this right here, right, because we would be copying the value, and we don't want to copy the value. We want to work directly inside the grid, and for that we need a reference. And how do we get the position from the index is very simple. We divided it by the width of our board. So remember, when we're using variables here that are not declared inside the function, it probably means that they are declared inside the structure. So I don't need to say, for example, that this variable comes from here, right? I don't need to tell it, the compiler just knows it. And I'll say that the index divided by the width will be the row position, okay, and the modulus will just be the height. Alright, not the height, sorry, the x and the y. So this is some basic math. If you do the math, you'll probably understand what I mean. And then we're going to break the cycle. Okay, so this is just a nice little function to place food in our board. And when we're using this function rand, alright, we need to include, I don't know why it's not here, but we need to include two things. The C time, no, just one thing, sorry, the C time. And you'll be wondering, wait, what does the random function has to do with the time? Well, when we create our game, we're going to set a seed. Alright, and we do that using this expression right here. And because the random function is not really random, it's created by a seed. You know, you have the seed and then you have the random numbers. The seed is what generates the tree of random numbers. So if you have the same seed for two programs, the random numbers that they will generate will be exactly the same. So we want a very unique seed, so it looks random, and for that we just pass the time. Right, and we need to cast this to an int because the seed works with integers and our time returns something else. Okay. Alright, so now we need to implement a very strange function which I'll call it rep. Okay. And what the rep does is it translates some position. Alright, so if it checks if some position is outside of the board, and if it is, it wraps it around and changes the position accordingly. So you'll see what I mean in just a second. And notice that I pass a reference, so I don't make a copy of the value. I actually work directly with a value that's passed as a parameter. So I'll say if the position is less than 0, I'll say that the position is in the right side of the screen. So if the snake, for example, goes to the leftmost side of the screen, so her position is -1, it means that she has just wrapped the screen. I don't know if this is an appropriate word, but it means she has gone beyond the screen and now she needs to return, and where she returned from is from the right side. So we'll just make this big leap, right, from -1 to with -1, which is the farmost position to the right. Okay. And then we'll say that if the position is too far to the right, we want to set it back to the left. And we do that also to the vertical position. Alright. It's very important that we use references here, because if we weren't, these values would be acting upon a copy, and we don't want a copy. We want to work directly with what's being passed as a parameter. So make sure you use the reference right there. Alright, and now I think we're ready to start working on the run. So we'll just say that the snake, and we need a snake. So let's just go here and put the snake over there, and we'll say that a snake, it's alive, and we need to set the position of the snake. Alright, so we'll set it to the bottom center of the screen. The int x will be the board width divided by 2, and the y will be the board height -1. And the snake head will be a point with x and y, and the snake position will be the exactly same thing, but we're going to cast it to a float, because our position point is a point float. Okay, and now we need to call board place food, so some food is placed on our plate, and we'll say that growing is equal to 3, equal to 5. Okay, maybe we'll change this afterwards, but just to make sure that it's working, just put 5 over there. So in the initial when the game runs, the snake will be growing 5 times, which means that she already has eaten 5 fruits. And I know this doesn't make sense, but just to see if our game is working, just put 5 there. Game loop. And we need to implement the game loop now. But let's take care of some basic functions first. We need a function to get the score, and we need a function to get the size of the snake. So this will be used by the main file, and it will just get how big our snake was in the end of the game and how big our score was. So for that we need to implement that, and the const keyword just says that this function will not change any member fields from the class. So it just says that, okay, look, this function will not mess up with anything from the structure I'm working with, it will just do its own thing. And for that we're just going to return score, and we need to get size, and we're going to return the snake size. Okay. Now the game loop. The game loop is probably one of the most difficult understood things, and I don't think I'm the best person to explain this, but I'll try my best. So first we need a frame rate, right? So is our game going to run at 60 frames per second, 30 frames per second? What frames do we need? Because we will be working with a fixed frames per second, which will simplify our game. So let's just do that, and don't worry about what I'm going to write over here. Okay, so const expression without the Asian just tells our compiler that we want to just make this calculation at compile time, right? So just make it right away when it compiles, so it will replace this value with the result. And uint32 is just a special type in C++ that we're going to need to use because of SDL, and we'll be working with SDL values from the library, and they use uint32 just to make things simpler. And our frame rate is basically how the frame rate, what it is. The frame rate is how many milliseconds between frames. That's basically what it is, right? So it's how many milliseconds between frames, and we use this calculation over here. Just put 60 frames per second, right? And this will not return the exact amount. It will return an integer amount, but that's okay because we don't really care about precision. We're just trying to make things simpler. And we want the time before, after, and the frame time. Okay. So these values right here will be used in our algorithm. You'll just see in a second, and this will just keep track of when did we show the FPS, right? We need to show the FPS to the user each second, and this just registers the time that we have shown the user the FPS. So if we were showing the FPS like every update, it would be very it will be very inefficient, right? Because you would be telling your user, okay, here's the FPS, right? That's a bummer. And if you do that each second, it's a lot smoother. Alright, and then we'll just have a variable which counts the frames, and this will be used to count the frames per second, and you'll see in a second. So while our game is running, okay, we'll get the time with this special function SDL get ticks, and this just returns the time, right? So we'll get the time before anything, and we'll do our game logic right here. So polyvents, update, and then render. This is the three basic functions of any game engine. And we'll say that another frame has been rendered, and let's get the time after our game operations. And our frame time will be the after last before. So before the time before our game game mechanics, doing stuff, and the time after these operations. And the time it took for the frame to be rendered is of course after minus before. And if after minus second, which means that 1 second has passed, is greater than 1000, which means that the time between the last second is exactly 1 second, it means we're going to update the frames. So we'll just say the FPS is equal to the frames will go back to 0. The second, which means the time that we have shown the FPS, which is right now, is going to be the after, and we're just going to update the window title with this information, right? And alright, this is working fine, but one thing's missing. So if you look at this code, you'll see that nowhere in this code we're kind of letting the computer to breathe, right? We're just doing a while running without stop, and this will cause some issues because our CPU will get overheated. Something happened with my CPU. I was doing like a game in Java, and I used a game loop similar to this one, and I didn't put any code to wait, right? Because FPS means what? Frames per second. It's not an infinite frames per second. So you want to wait between frames. If you don't wait, your CPU can get heated. And what happened to mine was I was just doing some coding and my computer just turned off, and I was freaking scared because I thought something had exploded within my computer, but then I just realized it was bad coding. So yeah, we need to say that if the frame rate is greater than the frame time, which means that we still need to wait more. It means that we still need to wait more time that it has taken so far. Okay, and if that happens, we're just going to wait the remaining time. Alright, and we do that using the SDL delay. So these functions are from the library and are very useful. Right, so this means that if we have reached the end of a frame means one image, and not sufficient time has passed, we don't need to render a new frame right away. We can just wait a little bit, some milliseconds, and then do the entire thing all over again. Alright, and now we need to define these functions: update, render, and polyvents. If we go to our header file, alright, we'll see we'll still have polyvents. Okay, polyvents is a very library specific type of thing, and SDL facilitates us with a lot of easy functions to use. So we'll just say that we want to register an event, and while there is events to track, so polyvent, so you just pass a reference to you'll pass a pointer with this notation to this function, and this function is going to see the pointer, and it will go to the pointer, and it will find our variable right here, our structure, and it will fill it with information about an event that has just occurred. And if no event has just occurred, polyvent or if all the events were taken care of, poll event will return 0. So the while statement will just break, and this will work just fine for us. So while there's an event that needs to be taken care of, if that event has the type str quit, it means our user doesn't want to play anymore, and so we'll say running to false. Else, if the type is not quit but it's some key that's being pressed down, we want to know which key it is, right? And we'll say that we want to access the key symbol, and the symbol, and if it is the up key, we want to say that the snake will be moving upwards. We want to break. Now STL key down, the snake will say that the snake will be moving downwards, and we'll do the same thing for the left. And for the right. Alright. Okay, so now we're just going to press tab to make this look beautiful. Alright, and one thing that's missing is that if you've played Snake before, you cannot actually turn downwards when you're facing upwards, right? So if the snake is walking to the right, it cannot turn to the left. It just won't work, right? So you need to turn up or turn down, and then you can move left. But you cannot move left when you're moving right, and you cannot move up when you're moving down. You cannot move down when you're moving up, and you get the point. So we need an additional if statement. So if our last direction was not down, or the size of our snake was 1, right? Because if our snake has size 1, which means it's just a hat, it can do whatever it wants. But if it's not 1, then we can only move up if we're not moving down. And we're going to do the same exact thing to the other directions. Left, right, and up. Okay, this is beautiful code, guys. You must understand that. This is just beautiful, right? Alright, this is not the most beautiful code, but the rest is pretty beautiful. Okay. Now, let's see. These will be the most arduous functions to implement. Let's just see if we've taken care of everything. Alright, I think so. Alright, so let's just do the update stuff. Okay. And for that, I'll just do it right like this, so we have more space. Okay. So update. If our snake is not alive, then we don't want to update anything, right? We just want to, don't do anything. Otherwise, we want our snake to move, right? And also, we want to wrap the snake position. What this does, first, it moves the snake, and it tells the board to change the position in case the position is not inside the board. Right, so if our snake goes over the rainbow. Alright, so if our snake position is too far to the left or too far to the right, our board will just say, "Oh, you don't belong here," and it will reset the position. So if our snake is walking to the left, it goes over to the left side. Our board will update the position to the farmost right side. Okay, and then we need to create a new position. A new position which will have the integer values of the snake position. So remember that the snake position is in floats. Well, our grid doesn't work with floats, it works with integers. So when we check when we work with the snake position inside our board, we need to work with integers, so make sure you have done this. And this is just a nice formatting for this right here, okay? Right there. It's the same thing. Okay, so now we're going to make an alias. An alias is just like it's just a nice convenient way to say snakehead. So you're going to use head instead of snakehead, and the reference makes sure that we're working with snakehead and not making a copy of it, right? This is the same thing as not doing anything, but I just don't like to use snake.head all the time, so I'll just use head. Alright, so we need to check if the head position has changed. Alright, so if our position x is not equal to the head x, or the position in the y coordinates has changed, it means our head position is not the same, so we need to update everything. Alright, so if our position has changed, then we'll just say that our last direction is going to be the current direction. And I don't know a better name for this variable. It just makes our game smoother. If you don't use this in our algorithm, it's the controls are not going to be very smooth. So yeah. Now, if we are growing, just make a new neck, right? So if we are growing, which means that the snake growing is greater than 0, it means we are still growing, we still have body to grow, and just make a new neck. So if our head position has just changed, which means that we'll have like an empty gap between the head and the body, and that empty gap will be the position of our neck, of our new neck, right? We'll just increase the size of the snake. We'll say that the head position will now be part of the body, and don't worry about pushback, it makes a copy, so it doesn't use the head. Inside of this function, it actually makes a copy of the head, and our head is just a point, so we could just say that the head is now the body. And we'll say that the snake is growing 1 unit less. And now we're going to our grid on the board, and we're going to say that now the head position is the body, and we're going to use this index right here. So this bracket stuff, this bracket notation, is a very helpful notation that C++ offers us for vectors. So it just works like arrays or lists, and we'll say that we want to go to the grid to this index, which is basically the x and y position, and we want to fill it with a block of body. Alright, this is if we are growing, right? If we're not growing, we need to shift the entire body. So imagine if this is our snake, right? We're moving to the right. If our head moves one time, right, we'll have this empty gap. If we are growing, we can just fill this with a new neck, like we did. But if we're not growing, we need to shift the entire body like this, right? You get the point. Like this, just to make my point very clear. Alright, and you'll have an empty block in the end. So let's just shift everything. So we need to shift the body. We'll just, in our algorithm, we'll use a 3 point, which says that the gap that we still need to shift to. So this is the gap, alright? The gap is now in the head, and we'll have to shift the entire body, so we need a way to walk through the entire vector, and for that we use an iterator. And this is the notation we use. So we want a reverse iterator because we want to go from the neck to the butt, and we'll say that we'll start from the beginning on the right side. So these R means from the right side, and begin, it means we're beginning a reversed iterator from the right side. We're going to from the right to the left. And until we have reached the end of our body, we're going to apply the algorithm to every body part. And basically we'll just say that the free gap will now be a body, right? And we're gonna swap between our gap and our body part. So what this is, it will switch this value with this one, and we'll do that for every single body part, right? And this is a very handful function that just swaps these values. Like 3 will have this value, and this value will have this value. If you did not use this function, you have to use at least one more variable to make the bridge. So you can try it yourself. And then in the end of the algorithm, we'll just have the 3 point will be the butt, right? Will be the last empty gap, you know, not the gap, but the last empty spot. And that's empty, right? Because we have just shifted the entire body, so that's currently empty. Okay. Now in the end, we'll say that the head will be the new position, alright? The head is now the new position. We've done the translation, and the head is now the new position. And now we must see if the block that our head is on is either a body or a food. If it's a body, it means we have lost. If it's a food, it means we have just grown in size. So we'll call that block a target, and it's basically the value of the grid where the head is, right? We need to check if there's food over here. If there's food over here, which means that the target is a food, we need to increase the score, we need to place a new food, right? And we need to say that the snake is growing 1 time. So if you wanted the snake to grow two body parts, you put 2 here, 3, 4, 5, whatever you want. And now we need to check if you're dead, right? Alright, so we'll just put snake alive of equals to false. So if the head is now in the position where the body is, it means we have just collided with ourselves, so we just put the snake alive equals to false. And now the target in the end will just be the head, right? Because we have not updated the grid yet. Like, we have done everything but just for the body, nothing for our head. So we'll just update the grid, right, with our head. not my head, snake's head. Alright. And very nice. Now we need to render everything we have just done to the screen, right? So if you run our program, I don't know if this will work. Let's see. Right, we have some errors. We'll fix those afterwards. But we need to render to the screen. And for that, we're going to render what? We're going to render squares. If you've looked into my game, like on the first part, you've seen that everything that was displayed on the screen was basically just squares. Squares for empty blocks, squares for head blocks, body blocks, and food blocks. So we'll just create a block, and SDLRect is a renderable square, right? And the width is basically the width of our window divided by the width of our board, and the same for the height. So if you have like if your width of the window is 100 and the width of your board is 10, 100 divided by 10 is 10. Your block will be 10 pixel width. And then you have to render first. Let's clear the screen, you know, because every time we want to render something, we have to clear everything and start to render on top of that. And for that, we just do set renderer draw color, and we'll just set some gray values right here. So this is red, green, blue, and alpha. You can write from 0 to 255, or you can use the hexadecimal notation, which makes it more interesting. And the renderer we'll have to use the SDL context renderer, but I don't want to repeat SDL context renderer all the time, because you're going to use the renderer a lot of times. So I don't want to. This is too big. I don't want this. So what we'll say is that the renderer. Alright, so we'll just do this, right? We'll just copy the pointer. It's a pointer, so we can just copy it. No worries. A pointer is just something that points to some structure, and we can copy the pointer because all pointers just point to the same thing, right? And then we want to render clear with our renderer, right? So first we set our colors, and then we clear the screen. And now we want to render the food. So first let's change our render draw color to some white stuff. So you can use any colors you like, just make sure it looks good. And then we're going to iterate over the food vector, and we do that using this notation. So double column, here the declaration for what you're going to iterate. Here you're going to put the vector or the structure that you're going to iterate over, and here you're going to declare the variable that will be responsible for that. So like every time, for every element in our board food vector, if you see here, our food is a vector of points. We'll run this code for each point of those, and use references not to make a copy. Alright, so here we say that the x position of the block will be the point, right? The x point, which will be the coordinate in the board, times the width of the block. So this translates to the actual x coordinate on our window, right? Because our point is not a real coordinate, this is a coordinate for our board, which in our case is from 0 to 32, from 0 to 31, because it's 32 of size, and so we need to multiply that by the width of the block, which we calculated over here, and that will give us the actual position to render to the screen in terms of pixels. Okay, and after doing that we need to render fill rect, and for that we just use this function right here, which takes a renderer and takes a pointer to a block, and you generate a pointer by using this thing right here. This is not a reference, don't confuse the two. You cannot generate references using any type of notation. You need to declare them. You can only create references, quote unquote, by declaring them. You cannot do them on the fly. And then we want to render the snake's body, right? So let's just use some nice color for the snake. Alright, we'll just say it's white. This is white color. You'll notice that I always use the same value for the alpha, because I want it to be opaque, right? I don't want it to be translucent nor transparent. I want it to be a solid color. And now I'm going to iterate over the snake's body, right? Using the same type of for loop we did over here, and we'll just say that the positions are this right here, right? And we're going to render it to the screen. So basically this code is almost the same as this one. We're just going to iterate over different vectors and using different colors. Now we want to render snake's head. Okay, and whoops, and for that we need a special color. We'll say that if the snake's alive, we want a different color, right? And if the snake is dead, render a draw color. We want a red, right? Red color to tell our player, fuck, you just messed up, man. You just died. Alright. And we need to update our block position too, so don't forget about that. Just the same thing we did over here. You could probably put this into a function that, but it's just, we're just going to use it 3 times, so no need to, I think. I think it looks good this way. And then we're going to render it to the screen. So make sure you render first the body, then the food, then the body, then the head, because you don't want, for example, the food to be on top of the head when the snake eats it, or you don't want the body to be on top of the head when the snake dies, right? Because you will not know where the head is if the body is on top of the head, right? And then you want to update the screen, right? Because the screen won't update itself automatically. Well, it will, but it needs some help, and this is what this function does. So everything we did over here is just basically drawing on a background image that we're going to render to the screen, and in the end we just render it to the screen. Because if we actually render it to the screen like in every step, first it will be very inefficient, and second, if our computer is slow, we'll see the pixels like showing up, and we don't want that. We want like pachow, we want to show the entire thing right away, and we do that by updating the screen just once per frame, or I mean per render function, render call. Right, and I think we have implemented almost everything. Let's just run it to see what happens. So in our main file we need to include our snake, and what we're going to do here is we're gonna create the game, right? We're gonna create the game, we'll run the game, and we'll just say game has successfully exited. Score, game get score, size, game get size. Alright, oops. So what this does, it opens up a stream that we can put stuff on to print on the console, and this operator writes what's on the right to the left, and we can do a chain of operators so it looks nice and sweet. So basically we're writing all these things to this stream over here, and this stream will print to our console, and this is the last value we use, and it basically just puts a new line. So it's like pressing return, and it flushes everything, so it actually pushes everything that we have just written to the console. And one last thing that we need to be careful of is that in the beginning of our program we have thrown exceptions, right? We have thrown errors right here, and C++ won't tell us about any errors until we have looked for them. So we're going to run our game, and we're going to catch any exceptions. And if any exception happens, we're just going to print it to the screen. And we need to put this over here. Alright, and this should probably work. Let's see. Of course it doesn't work. Errors. Right guys, so I just had a major headache trying to find a bug. Right here, don't forget that e.what is a function, so just put the parentheses over there and you should be good to go. Now there's one little problem, not a problem, but a thing I haven't told you, that you need to put return 0 right here, because the library requires that your main function be in a certain way, so you are not allowed to change any of these types, and you must return some value, right? So 0 is usually defined when your program runs successfully. So if it all works, you just return 0, and that's what we're going to do. And here we're trying to run this code. If there's any exception, we're going to catch it using a reference, so we don't make a copy. And we use const to tell the compiler that we don't intend to move or change this exception, we just want to see what's inside, and we do that using the what. Now be ready for some errors when we try to run the code, and there are some errors, of course. Right, so on Snake CPP, on place food, the size is actually a function, so just put the parentheses there, right? And our game is kind of working nice, but there are some errors and we want to fix those. Right here on wrap, you want to cast the value to the type of our position, so just put that static cast, and this is 0, so you don't need to do that because every value has 0. And this is good, so control F5 again, and nice. So there's one little bug, the food doesn't disappear, and I know why this is. So we're only going to need one food, so let's just replace the vector with a point. Okay, and here we'll just say that food.x will be index, and food.y will be this. Alright, so this way we don't need to deal with vectors, and we're not using them anyways. So another thing on the render, right, we don't want to use loop, we want to use the food, right? So food y and food x, and it's border.food, so type that in, control F5, and no errors. Alright, so we have our snake game. Alright, and it's working very cool, very fine. Alright, no bugs. Score 4, score 3, score 5, score 6, and the wrapping stuff is working nicely. Nice. Alright. Right guys, I hope you enjoyed it. Alright, game has successfully exited. Score 6, size 12. Press any key to close this window. If you have any question, just put your question on the comment section below, and I'll answer it, or make sure you understand every piece of thing. And one last thing, if you want your game not to show up that ugly console window, you can just go to to properties and system, and on subsystem you just put not set, right? And just press OK, and if you do control F5, entry point to maybe not set, maybe Windows, I think it's Windows. I think Windows works fine, and yeah, you just can catch the food, and if you collide with yourself, you'll see the red thing right there, red head, and you just click X to exit, and everything works beautifully. One last thing I'm going to do is on the snake, when we start the game, which is on run, I'll say that the growing will just be to 0, okay, because I want it to be like a single dot right here, and if I catch some food, alright, beautifully. So thank you very much guys, please give me a like if you enjoyed the video, and post your comment below if you liked it. If you didn't like it, let me know, and see you next time.